All right, today we're going to be looking at how to prove triangles are congruent. So that means we're going to go back to our notes on proofs for just a moment and try to refresh our memory on how to use proofs. Remember, proofs, we have two columns of statements and reasons. Statements are mathematical operations, and the reasons are the properties or theorems that allow us to make those operations. So when we apply that to proving that triangles are congruent, we can use those same properties to do that. So here you see here example triangle ABC and triangle XRW, trying to prove that they are congruent. We are given that segment AC is congruent to segment XW, so we are given that. We are given that angle C is congruent to angle W. Again, that is a given. And we are given that angle A is congruent to angle X, and that is a given. Now, if those markings were not already there on the drawing, I would want to make sure that I put those there. So AC and XW, I'd want to put a tick mark on that segment to show that the segments are congruent. Angle C and angle W, I'd put a single arc mark, and angle A and angle X, I'd put a double arc mark to show that I have two angles that are congruent. Now, to prove that triangle ABC is congruent to triangle XRW, I have enough already to prove that because I have angle, side, angle. So I have angle, side, angle, and that is enough to prove congruency. So that is our reason there. All right, so if you look here at the bottom of this page, we are given that segment AD is congruent to segment CB, and we mark that with a single tick mark. We are given that segment AB is congruent to segment CD, and we mark that with a double tick mark. So let's go ahead and write those statements in. Segment AD is congruent to segment CB, and that is a given. And we have segment AB is congruent to, I'm going to flip back and forth, hopefully this follows along. Next, we have a line from BD that is congruent with itself. So ABD is congruent to triangle CD. And that is a given. Put that there. Segment BD is congruent to itself, segment BD, and that is the reflexive property. Technically, it's the reflexive property of congruence. And that allows us to say that those two triangles are congruent, triangle DB. And the reason why is side, side, side. All those sides, we have three sides of congruence. So that's enough. Side, side, side. All right, next we have segment AB is congruent to segment DB. So I'm going to go ahead and mark that, because it's not already, with a single tick mark, and go ahead and put that on our proof. And that is a given. We have angle A is congruent to angle D, and that is a given. And we can go ahead and mark that with a single arc mark. Angle A congruent to angle D. Now, one more thing we can infer from the drawing is that we have a pair of vertical angles. We have angle ABE is congruent to angle DBC, because, we can go ahead and mark those with double arc marks, because the vertical angle theorem, or you could say vertical angles are congruent. Either way, it means the same thing. So now I have a pair of angles, a pair of sides between, and then another pair of angles. So that means I have angle, side, angle, and I can prove that triangle ABE is congruent to triangle DBC because of angle, side, angle. All right, next, I went ahead and redrew that drawing that was on the previous page at the top of this page, just so that I didn't have to flip back and forth so much. We're given that segment GH is congruent to segment KJ, so we'll mark those with a single tick mark. Segment HL is congruent to segment JL, and mark those with a double tick mark. And we'll go ahead and mark those statements down in our proof. GH congruent to KJ, that's a given. HL is congruent to JL, and that's a given. The other given we're given is that L is the midpoint of segment GK, and that is a given. Now, we can't really mark anything with that, but what that does allow us to do is infer that segment GL is congruent to segment KL, and that is the definition of a midpoint. So we can go ahead and mark that congruent to each other with a three tick marks. GL is congruent to KL. And with that, now I have enough to prove that triangle GHL is congruent to triangle KJL. And that is because I have side, side, side. All right, that is it for the notes for today. If you have any questions, please don't hesitate to ask. Reach out with a Canvas message or an email. Have a great day.